Number 10. The duck that was secretly a raptor. Let's start with the one that scientists were sure had to be a fake. When this fossil first surfaced, sealed in a block of stone from Mongolia, it made no sense at all. It had the long, graceful neck of a swan. It had the flat, round-tipped bill of a duck, packed with dozens of tiny teeth. It had short, flattened forelimbs that looked, for all the world, like the flippers of a penguin. And it had the killing claws and long tail of a velociraptor. It was such a ridiculous mashup of parts that researchers assumed someone had glued several different animals together and salted it onto the fossil market, which, it turned out, was exactly where it had come from. The specimen had been poached and smuggled and passed around private collectors for years. So before they would put their names on anything, the scientists did something clever.
They took the fossil, still half buried in its rock, to a particle accelerator and blasted it with high-energy X-rays to see straight through the stone. And the animal was real. Every impossible piece of it belonged to one creature. They named it Halscaraptor. It was a raptor, a close cousin of Velociraptor, about the size of a goose. But instead of chasing prey across dry ground, it had gone to the water. That swan neck was for darting the head down to snatch fish. Those flipper-like arms were for swimming. That bill was riddled with tiny channels for nerves, the same sensory trick crocodiles and ducks use to feel for prey in murky water. There is a whole hidden backstory to how it reached science at all. Because it had been looted rather than properly excavated, no one even knew for certain where or when it had come out of the ground. It drifted through the private fossil trade for years. A dealer finally handed it to researchers, who later arranged to send it home to Mongolia. Its name honors Halska Osmolska, a Polish paleontologist who spent her life pulling strange dinosaurs out of that same desert. And once scientists knew what to look for, they realized it wasn't alone. It anchored a whole small branch of oddball, probably water-loving raptors, a corner of the family tree nobody had known was there. It wasn't even the first raptor suspected of fishing. Down in South America, a separate branch of the raptor family had already evolved long, slender, fish-catching snouts. But none of them committed to the water the way this one did, with the flippers and the swan neck and the whole waterbird posture. One paleontologist summed it up perfectly, calling the creature a kind of toothed, short-armed pseudo-goose. It is the closest thing the dinosaur world has ever produced to a platypus, a predator assembled from a grab bag of other animals, that no one would have believed if the bones hadn't proven it. A raptor that decided to become a duck.
Nature, apparently, was feeling playful that day. Number 9. The giant behind the mystery arms. In 1965, an expedition in Mongolia pulled a pair of arms out of the ground that stopped paleontology in its tracks. Each one was over 8 feet long, longer than a person is tall, ending in 3 enormous curved claws. And that was all there was. No skull, no body, just these 2 colossal limbs, hinting at some titanic predator. The name they got says it all. Dinosaurus, meaning horrible hand. For half a century, that was the entire mystery. Everyone assumed the arms belonged to some unimaginable killer, a monster that would dwarf Tyrannosaurus. And every so often, an artist would draw a nightmare to hang beneath those claws. And the name stuck for a reason. Those arms were the stuff of legend in paleontology, precisely because they promised a monster and then made everyone wait 50 years for the reveal. They were all wrong. In 2014, new skeletons finally revealed the whole animal, and it was not the killer anyone expected. Dinosaurus was gigantic, yes, around 36 feet long and heavier than 6 tons. But this was a slow, harmless browser. Its long skull ended in a flat, toothless duck-like bill. A tall sail or hump rose off its back. A bulky, pot-bellied body churned through mountains of vegetation. And those famous, terrible claws were most likely for raking up water plants and hooking fish out of the mud. For those 50 years, the guesses ran wild, and they were reasonable guesses. Nothing about a pair of 8-foot arms said gentle. The claws alone were the length of your forearm. Some researchers thought the arms might belong to a giant relative of the ostrich-like dinosaurs. Others suspected something entirely new. The problem was that arms, by themselves, lie. Long arms with big claws sound like a killer. But the same tools work just as well for a giant that wants to pull down branches or drag plants out of a riverbed. When the rest finally came out of the ground, almost every part of it was a surprise. The skull was long and low and ended in a wide, flat, toothless beak. The mouth of a browser, not a slasher. Inside the body cavity, paleontologists found fish scales and hundreds of swallowed stones, gastroliths, the gizzard grit of an animal grinding up tough plants and soft river prey. It had lived in a wet, marshy world and made its living wading, not hunting. And, like the arms that had haunted the field for half a century, the rest of the skeleton had also been poached. The skull had to be tracked down and repatriated before the full picture could finally be assembled. Picture something like an enormous, humpbacked, feathered ostrich the size of a bus, wading through a swamp.
For 50 years, we imagined a demon on the end of those arms. What we got instead was one of the most wonderfully improbable animals the Cretaceous ever produced. Number 8. The dinosaur that tried to become a bat. Some of these animals stand out for how they lived. This one stands out for a road evolution almost never takes. Nearly every flying or gliding dinosaur solved the problem of getting airborne the same way. Feathers. Long, stiff feathers spread into a wing. That is the road that leads to birds. But one little dinosaur, about the size of a pigeon, living in the Jurassic forests of China, did something almost no one believed when they first saw it. Sticking out from each wrist was a long, thin rod of bone, a strut found in no other dinosaur, anywhere. At first, some researchers thought it was a mistake, maybe a stray plant stem lying across the fossil. It wasn't. It was part of the animal. That rod, it turns out, supported a wing made of skin, not feathers.
A thin membrane stretched between the finger, the strut, and the body, exactly the way it works in a bat or a flying squirrel. This creature, called Yi Chi, had independently invented the bat wing, tens of millions of years before bats existed. It is one of the only dinosaurs known to have flown on skin instead of feathers. When the fossil was first described, one of the world's leading dinosaur experts admitted he had assumed the strange wrist rod was a fluke, a twig or shard of something else that just happened to lie against the bones. It took a second animal to settle the doubt. A few years later, a close cousin turned up, also with the same bizarre wrist strut, and also with a preserved film of skin along its arm. The membrane wing was real, and it had happened in more than one of these little tree dwellers. They belonged to a short-lived group of tiny, climbing, insect and seed-eating dinosaurs that lived up in the Jurassic canopy, as far from the popular image of a dinosaur as it is possible to get. There is a lovely lesson buried in this failure. Flight is so useful that life keeps reaching for it, and it turns out there is more than one way to build a wing. Pterosaurs stretched a membrane on one long finger. Bats stretched one across several. Birds went with feathers, and for a brief moment in the Jurassic, this little lineage tried the bat's trick on a dinosaur's hand, complete with its own custom-grown support strut, and very nearly pulled it off. Evolution, it seems, doesn't find the best answer. It throws everything at the wall and keeps whatever doesn't fall. But here's the poignant part. It wasn't very good at it. When scientists modeled how Yi Chi actually moved through the air, the verdict was gentle but clear. It was a clumsy glider at best, incapable of real powered flight, only able to lurch from tree to tree. Its whole strange lineage appeared, fumbled around in the branches for a few million years, and then vanished, losing the sky to the feathered birds. Yi Chi is a rare thing in the fossil record. It is a snapshot of an experiment that failed, A beautiful wrong answer to the question of how to fly. Number 7. The predator with a hump nobody can explain. Not every mystery on this list has been solved. This one is still open. Concavinator was a meat eater from what is now Spain, around 20 feet long, a respectable predator but not, on the face of it, a headline act. Except for one thing. Just in front of its hips, 2 of its backbones shoot upward into tall spikes, forming a strange, narrow, pointed hump that rises out of an otherwise sleek body. And nobody knows why. It doesn't sit where a heat-regulating sail would make the most sense. It's too far back and too oddly placed to be an obvious fat store. It might have been a display structure, a bright flag of skin, to show off to mates or rivals. The honest answer is that this is one of paleontology's genuine open cases. The predator has a spike on its back, and the reason went into the ground with it. What that hump was actually for keeps sliding between explanations. Because the tall spikes sit over the hips rather than the shoulders or the middle of the back, the usual tidy answers don't fit cleanly. A cooling sail would work better spread along more of the body. A fat store, like a camel's hump, is possible but hard to prove from bare bone. The idea most researchers keep returning to is display, a structure held up on skin, perhaps brightly colored in life, meant to be looked at. But the truth is that the fossil simply does not tell us, and honest scientists say so. It is a reminder that even with a good skeleton in front of you, some questions stay stubbornly shut. It helps that this predator was buried in one of the finest fossil sites in Europe, a place where soft tissues sometimes survive, which is the only reason those tiny arm bumps were noticed at all. In a normal, rougher fossil, they would have been lost entirely, and the feather question would never have come up. Which raises an uncomfortable thought. How many other predators carried quills or feathers that simply rotted away, leaving us to picture them, wrongly, as bare and scaly? There is, though, a second detail on this animal that turned out to matter far more than the hump. Along one of its forearm bones, scientists spotted a row of small bumps. In modern birds, bumps in exactly that spot are quill knobs, the anchor points where the shafts of large feathers attach to the bone.
If that is what these are, and it is still debated, then a big, sharp-toothed predator was carrying quill-like structures on its arms. That would push feathers deeper down the dinosaur family tree than many people were comfortable with. The mystery hump gets the attention, but it may be those little bumps on the arm, easy to miss, that quietly rewrote part of the story of feathers. Number 6. The Mesozoic cow with a see-through skull. Time for one that is less terrifying and more, frankly, ridiculous. When the paleontologist Paul Sereno first got a good look at this dinosaur's skull, he called it the weirdest dinosaur he had ever seen. And then he compared its face to a vacuum cleaner. He was being accurate. Nigersaurus was a long-necked plant eater from the Sahara of 100 million years ago, and its head is one of the oddest-looking skulls ever mounted on a long neck.
The snout is wide and flat and squared off, like the nozzle of a vacuum, wider than the rest of the skull. And along the front edge of that mouth sat a truly absurd piece of equipment. Nigersaurus had over 500 teeth. Not 500 over its lifetime, 500 in its mouth, arranged in tight rows like the blade of a lawnmower, and it burned through them constantly. Every single tooth was backed by a stack of replacements, and the animal grew a fresh one in each position roughly every 2 weeks. It held its head low to the ground and ran that vacuum mouth across the plants like a living lawnmower, shearing everything off and grinding it down with an ever-renewing wall of teeth. To understand how it fed, scientists did something that had never been done with any dinosaur before. They used medical scanning to build the very first digital reconstruction of a dinosaur skull, piecing the fragile, shattered bones back together inside a computer. What that model showed was almost comical. The balance organs in its inner ear revealed that Nigersaurus normally carried its head tilted sharply downward, its face aimed at the ground, permanently pointed at the salad. This was not an animal that reached up into trees like other longnecks. It was built, from the shape of its inner ear to the vacuum edge of its jaw, to be a ground-level grazer, mowing the low plants of an ancient river delta. The numbers behind those teeth are worth sitting with. More than 500 teeth in the mouth at once, and beneath every one, a column of replacements stacked and waiting, so that across a year, the animal cycled through thousands of teeth. It is one of the most relentless tooth factories evolution ever built. Bolted onto the front of a skull, so airy and delicate, it looks less like a weapon of eating and more like a wireframe model of one. It belonged to an offshoot of the long-necked family that had traded the usual towering treetop reach for a low-slung, ground-level design. And its whole body was tuned to that humble job of hoovering up the greenery near its feet. There is something almost sweet about it. Strip away the 500 teeth and the vacuum face, and what you have is a modest, cow-sized animal that just wanted to eat ferns in peace, wearing one of the most over-engineered mouths in the history of life to do it, and nothing else quite like it has been found since. The skull that held all this was so full of openings and so paper-thin in places that it was nearly translucent. You could very nearly have read a newspaper through parts of this animal's head. It is not the scariest dinosaur that ever lived. It might be the goofiest. But 500 self-replacing teeth in a see-through vacuum cleaner face is exactly the kind of thing the movies would never dare to invent. Number 5. The one that dressed to impress. If Nigersaurus was built for function, this next one was built almost entirely for show. Meet Cosmoceratops, a horned dinosaur from ancient Utah, a cousin of Triceratops, and quite possibly the flashiest head that ever walked the earth. Most horned dinosaurs have a few horns and a frill. Cosmoceratops had 15 horns and spikes crowded onto a single skull, the most ornamented head of any dinosaur we know. A horn on the nose, a long pointed horn over each eye, a horn jutting from each cheek, and then, along the top edge of its bony frill, a row of 10 more hook-like horns, curling forward over the forehead like a fringe of bangs. It helps to know where this fashion show was happening. In the late Cretaceous, a great inland sea split North America down the middle, cutting off a long, narrow western landmass. On that isolated strip, horned dinosaurs were stranded, evolving on their own, and something strange happened. Cut off from the wider world, they raced each other into more and more elaborate headgear, generation after generation. Cosmoceratops is the peak of that runaway process, the gaudiest face from a lost continent that was, essentially, running its own separate experiment in style. The evidence that this was about looks, not weapons, is written right into the horns. A defensive horn points forward toward the threat. Cosmoceratops's brow horns sweep out to the sides and curl downward over the eyes, in a way that would be almost worthless against a hungry tyrannosaur. The 10 hooks along the frill, curling forward over the forehead, defend nothing at all. Every line of that skull is angled for the eye of another Cosmoceratops, not for battle. When you strip away the assumption that horns mean fighting, what's left is unmistakable. This was a species that lived and competed through pure display, and it took that strategy further than any horned dinosaur before or since. Researchers who study these things have even measured how the complexity of dinosaur headgear changed over time, and the ceratopsians kept climbing, their frills and horns growing steadily more elaborate as the millions of years passed. Cosmoceratops sits near the very top of that trend, about as ornamented as the group ever got. It shared its lost island with other showpieces too, including crested duckbills and other horned dinosaurs, a whole ecosystem of animals seemingly competing to out-decorate one another. Here's the thing though, almost none of it was any good in a fight. The horns over the eyes, instead of pointing forward like a proper weapon, curved sideways and downward, which is close to useless for defense. And that is the giveaway. This wasn't armament, it was advertising. The whole Baroque arrangement was a billboard, evolved for the same reason a peacock grows an absurd tail: to be seen, to intimidate rivals, and to attract a mate. Cosmoceratops lived on a cut-off strip of land, an island continent where horned dinosaurs were evolving into their own isolated, ever fancier forms, competing not by fighting, but by looking spectacular. It is, essentially, the dinosaur that won by being the best dressed in the room. Number 4. The Tyrannosaur the movies never showed you. Everyone can picture a Tyrannosaur. Now, throw that picture away because it is only half the family. When you imagine a big Tyrannosaur, you see the bulldog, the massive, deep, muscular skull of Tyrannosaurus rex, built to bite through bone. For a long time, that was the assumed shape of all the big tyrannosaurs. But there were rumors, fragments, a few odd long snouts that didn't fit. And paleontologists argued for years about whether a slender, long-faced tyrannosaur had really existed, or whether those bones just came from youngsters. Then, at a construction site in southern China, workers uncovered a nearly complete skeleton that settled it. They nicknamed it Pinocchio Rex. Its real name is Chienzosaurus, and its snout was long, low, and slender, roughly a third longer than a typical tyrannosaur's, studded along the top with a row of small horns. This was a true tyrannosaur, a cousin of T-Rex living right at the end of the age of dinosaurs, but built on a completely different plan. Lighter, faster, with a narrow snout full of smaller teeth made for quick, slashing bites rather than bone-crushing power. It hunted the same world as the heavyweight tyrannosaurs, but went after different, nimbler prey. For years, this was a real fight inside paleontology. A few long, slender tyrannosaur snouts had turned up, but they were incomplete. And there was a reasonable objection. Young tyrannosaurs had proportionally longer, shallower snouts than adults. So maybe these long-snouted specimens were just teenagers that hadn't bulked up yet. Without a good adult skeleton, the argument couldn't be settled. That's why the Chinese skeleton mattered so much. It was clearly a grown animal, and its long, low snout wasn't a phase. It was the whole design. That design tells us something important about the last days of the dinosaurs. The world just before the asteroid wasn't ruled by a single tyrannosaur shape. In Asia especially, the family had split into at least two very different hunters sharing the same ground. The heavy, bone-crushing bulldogs, and these lighter, long-faced slashers going after quicker, smaller prey.
Recent digs in the very same region of China have even turned up a second, smaller, long-snouted tyrannosaur alongside this one, which suggests these narrow-faced hunters weren't a fluke at all, but a whole successful way of being a tyrannosaur that the movies simply skipped. It wasn't even the only long-snouted tyrannosaur in the family. An older, more fragmentary cousin from Mongolia had hinted at the same slender-faced design for years, and together, they show that this was a real and lasting way to be a tyrant dinosaur, not a one-off oddity. Line the two body types up side by side, and the contrast is almost comic. On one side, the famous bulldog, a skull built like a wrecking ball. On the other, this greyhound of a tyrannosaur, lighter and quicker and long in the face, chasing down whatever the heavyweight was too slow to catch. The king had a leaner, faster relative the whole time. He just never got the movie deal. The lesson is simple and a little humbling.
The famous king was never the only design. Right beside him ran a long-snouted, fine-boned relative that no blockbuster ever bothered to show you. Number 3. The dinosaur wearing 2 rows of spears. Some dinosaurs surprise you in the skull. This one surprises you down the entire length of its neck. Amargasaurus was a small sauropod from Argentina, one of those long-necked, 4-legged plant eaters, but shrunk down to about the length of a bus. and running down its neck and back was something no other sauropod has ever shown. Not one row of tall spines, but two. A double rank of long bony rods growing straight up out of its vertebrae in parallel lines. On the middle of the neck, the tallest of them reached about 2 feet in length. This was a gentle herbivore that appeared to be wearing a rack of spears on the back of its own neck. Start with what is not in dispute, because even that is remarkable. This was a sauropod, a member of the great long-necked lineage, but a peculiar downsized one, with a neck that was actually short by sauropod standards. Out of the top of the vertebrae in that neck grew the spines, and they didn't rise as a single ridge the way they do in other dinosaurs. From partway down the neck, each spine split into two, forming those two separate parallel rows, left and right, marching down toward the shoulders. Nothing else in the entire sauropod world is built like this, and it was described from a single skeleton found in Argentina, which remains, to this day, essentially the only one we have. That scarcity is exactly why the argument about the spines has never been put to rest. With one specimen, every interpretation rests on the same handful of bones. A recent detailed study of the internal structure of those spines found signs that they were bound together by tough tissue, which nudges the picture toward a skin-covered sail rather than a bristle of bare spikes. A close relative discovered more recently had similar spines that curved forward instead of standing straight up, which only deepens the strangeness. The double-speared neck is real. What it was dressed in and what it was for is still being fought over, one careful study at a time. It came from a family of these smaller, stranger long necks that seem to specialize in bizarre necks. A close relative found more recently carried spines that swept forward over its head instead of standing upright, aimed out past the skull like a crown of blades. Whatever was going on with this group, it was clearly important to them, generation after generation, because they kept investing precious bone into these elaborate necks. A big, slow, plant-eating animal does not grow a rack of 2-foot spines by accident. It grew them because something, a mate to impress, or a rival to warn, or a predator to bluff, was watching the neck. And what those spears actually looked like in life is a real and unsolved argument. One camp says the rods stood exposed, like a double row of naked spikes, or horn-covered lances, a fence of bone the animal could rattle or use to make its neck look enormous and dangerous. The other camp, backed by a recent close study of the bone, says the spines were wrapped in skin, forming a tall double sail or crest running down the neck. Spikes or sails, a mohawk of spears, or a pair of billowing crests. We genuinely do not know, and with only a single good skeleton of this animal ever found, we may not know for a long time. Either way, it is one of the strangest silhouettes the dinosaur world has to offer. Number 2. The digger with a single claw. This next one might be the hardest body plan on the whole list to explain, and for a long time, nobody could even agree what it was for. Mononychus was a small, lightly built dinosaur from Mongolia, only about 3 feet long, standing on a pair of long, slender sprinter's legs. It was covered in a shaggy coat of feathers. The bones of its inner ear were shaped much like a barn owl's, which means it likely had extraordinary hearing, and may even have had an owl-like disc of feathers on its face to funnel in sound. So far, so bird-like. And then you get to the arms. Its arms were tiny, stubby, almost comically short, pinned close to the body. Each ended not in a grasping hand, but in a single, stout, powerful claw. One finger, one claw. For years, this animal was a genuine riddle, so peculiar that scientists first wondered whether it was a dinosaur at all, or some early flightless bird. What do you do with 2 short arms, each carrying one thick claw? You can't catch prey with them. You can't climb. When it was first described, this animal caused a genuine crisis of classification. Everything about it seemed to point in two directions at once. The long legs, the light build, the keeled breastbone, the feathers, and above all, those owl-like ears, made it look startlingly bird-like. Its discoverers first placed it right at the blurry border between dinosaurs and birds. And then there were those absurd arms, which looked like nothing on any bird alive. The arms are the key to the whole puzzle, and they only get harder to explain the closer you look. They are not just short, they are reinforced. The elbow carries a huge bony projection for anchoring powerful muscles, the kind of leverage you'd want for driving a claw into something hard, over and over. Recent studies of how the shoulder actually moved suggest the animal could angle that single claw at a whole range of surfaces, hooking and pulling like a living pickaxe. Put it all together, the sprinter's legs, the sound-hunting ears, the feathered body, the one reinforced digging claw, and you get an animal with no real modern equivalent, a fast, sharp-eared, feathered runner that made its living punching into the fortresses of insects. It took paleontologists years just to agree on what they were looking at. In fact, when it was first named, some scientists were so struck by its bird-like traits that they classified it closer to birds than to the raptors it actually resembles. And the debate over exactly where it sits in the family tree ran for years. That confusion is the whole point of the animal. It sat right on the seam between our categories, refusing to be simply a dinosaur or simply a bird, a fast little feathered thing with an owl's ears and a pickaxe for a hand, assembled from parts that no living creature wears all at once. The best answer we have is that Mononychus was a specialist at breaking into the hardest food source around, insect nests. Those single claws were pickaxes, built to hack open the rock-hard walls of termite mounds so the animal could lick out the insects inside, the same living that anteaters and pangolins make today. A fast, feathered, owl-eared runner, crossing the plains on long legs, stopping to punch its way into a termite mound with the one tool it had. There has never been anything else quite like it. Number 1. The dinosaur you can still hear. We finish with an animal that looks strange, but whose real strangeness you can't see at all. You have to listen for it. Parasaurolophus was a large, common, duck-billed plant eater, the kind of ordinary background dinosaur that fills out any Cretaceous scene. Except for the thing growing out of the back of its skull. A long, curved, bony tube swept backward off its head, sometimes stretching more than a yard, like a great swept-back horn. For a century after it was found, that crest was a mystery, and the guesses were wild. A snorkel so it could breathe underwater? A tank of spare air for diving? A weapon? A prop to push through swamp plants? Every idea ran into a problem. Usually the fact that the crest was completely sealed, with no opening at the end. For 100 years, that sealed tube on the back of its head was one of the most argued over structures in all of paleontology. People genuinely proposed that it was a snorkel, imagining the animal walking along a river bottom breathing through the tip, until someone pointed out that the crest was closed at the end, with no hole to breathe through. Others guessed it was a storage tank of air for diving, or a snarl of extra strong bone for combat, or a tool for shoving aside branches. Every idea kept crashing into the same wall. The anatomy didn't fit. The crest was doing something, clearly, and it was costing the animal a lot of bone and energy to grow, but its purpose refused to reveal itself. And Parasaurolophus was not alone in this. It belonged to a whole family of crested duckbills, and each kind wore a different shape of crest. A rounded helmet here, a flat paddle there, a swept-back tube on this one. If the crests were instruments, then each species sang in its own register, a forest full of different living horns, each tuned to its own kind. Some had crests that changed shape as they grew, so that a youngster's voice would have deepened and shifted as it matured, exactly the way ours does. These were not the silent, hissing reptiles of the old imagination. They were noisy, social, talkative animals, filling their world with sound. Then researchers looked inside it, and the answer was more beautiful than any of the guesses. The crest was hollow, but not empty. Running through it was a set of long, looping tubes, folded back on themselves, connected directly to the animal's nasal passages and airways. It was, in the most literal sense, a wind instrument, a trombone made of skull. When Parasaurolophus pushed air up from its lungs, through those coiled internal pipes, the whole crest would resonate, and the animal would produce a deep, low, carrying call, a foghorn note rolling out across the landscape. Here is the part that gives people chills. Because the shape of that instrument is preserved in the bone, scientists have been able to reconstruct it, load it into a computer, and calculate the exact frequencies it produced. We have, in other words, rebuilt the voice of a creature that has been dead for 75 million years. You can walk into a museum today and press a button and hear it, the actual physical sound of a dinosaur calling. Not a movie roar invented by a sound designer. The real note pulled straight out of the geometry of its skull. The work behind that reconstruction is a small marvel of its own. Rather than sawing open a priceless skull, scientists ran it through medical scanners and mapped the twisting internal air passages in 3 dimensions. Then they treated the whole thing like an unknown musical instrument, calculating what pitch a tube of exactly that length and shape would sing. Different individuals with different sized crests would have produced different notes, which points to something almost tender. The possibility that these animals knew one another by voice, a young one able to pick out the specific call of its own mother across a crowded, noisy herd. The crest may also have served as a bright visual flag and helped shed heat, but its heart was sound. And it is worth saying plainly what that means, because it is easy to rush past. A creature vanished from the earth 75 million years ago. No human ear ever heard it. And yet, from the frozen shape of its skull alone, we have worked out the actual sound it made and played it back into the air. We did not guess it. We reconstructed it note for note from bone. Think about what that crest was really for. A herd of these animals, moving together across the Cretaceous, each with a slightly different sized crest, each with a slightly different voice, calling back and forth to one another through the trees. Warnings, contact calls, individuals recognizing individuals by the sound of a voice. The strangest thing about the strangest dinosaur on this list isn't a claw or a sail or a horn. It's that it was singing to its family. Finale. Line them up, and a single idea runs through all 10. The duck-billed raptor, the horrible hands that belong to a gentle giant, the dinosaur that tried to be a bat, the 500-toothed vacuum, the one wearing 15 horns, and the one wearing 2 rows of spears, the single-clawed digger, and the great crested trombone singing across the swamp. Not one of them looks like the dinosaurs you grew up drawing. The gray, scaly, roaring monsters of the old museum halls were never the real story. They were a rough sketch, drawn before we had the fossils to know better. The real dinosaurs were feathered and fluffy, humped and sailed and horned, clumsy and specialized and strange. An explosion of experiments far weirder than anything a movie has ever put on a screen. And we are only just starting to meet the real ones. And that is the quiet thread tying this whole countdown together. Nearly every animal on this list was, at some point, gotten wrong. The gentle giant was imagined as a demon. The swimming raptor was dismissed as a forgery. The singing dinosaur's crest was called a snorkel. Again and again, we looked at a handful of strange bones and filled the gaps with the most familiar monster we could picture. And again, the ground eventually handed us something stranger and truer than our first guess. So the next time you picture a dinosaur, try to remember that the truth was stranger. Somewhere in the Cretaceous dusk, a crested head tips back, Air moves through a coil of bone, and a low, mournful note rolls out across the water, answered a moment later from somewhere in the trees. That sound was real. It filled that world for millions of years, and we are the first creatures since to ever hear it again. Until next time.